Here we go. So I have all of week 14 in this video. So Monday, this is day 37. Do your best work at the end. As much as you want to just get things done, you know, you got your checklist of everything to do, the object is to still learn. And I mentioned that in previous videos, but Tech Den Network Tour, it's Wednesday, but it's that Wednesday in week 15. Okay. So it's next Wednesday. We weren't able to do it this week. So if you still want to participate, I'll remind the students on Monday. How we develop an information system, talk about the two approaches, and we do some more work on databases. Talked a little bit about backup. A review when students filled out the project 4. In there we talk about backup. You can back up to hard drive, you can back up to the cloud. If you're backing up to some specific device, you got to think about what if there was a fire in your house or something, or a flood, depending on where you lived, and so forth. So are you storing that off-site or in a fireproof safe? We talked about life cycles. We create something, it's productive, and then eventually it dies. And during the productive stages, we keep improving upon it. It's kind of like humans. We're born, somebody takes care of us, and then all of a sudden we're in productive stages, and we're always doing things to enhance our lives or the lives of those around us. Kind of like service leadership. And there's all kinds of checks during this productive stage. I gave the example, if you went out and ran, you would start to sweat, but you'd start to sweat before your body totally needs to be cooled. Your body tells you you're hungry before you actually have to eat and take care of the hunger. Smart, lets us know ahead of time. Believe it or not, a good information system will look at data, whether the data is coming externally or internally. It'll use software to tell us how to better manage whatever our information system's managing. And nowadays, with artificial intelligence, we're doing a better job of that. So it'd be artificial intelligence and something else known as machine learning, where we can adjust the software and the data to match whatever's current. It's interesting. So here, again, let me use a different color here. Workforce, levels of management, first line, middle, top level. We have our vendor partners we work with. And then on this end, we have external customers and all these other people communicating in with our information system. And the better we design this, the better these people can do their work, and the better our customers can better view and buy or whatever services we're doing. Crucial part of this are decisions, whether they're made by technology, structured decisions, or primarily made by humans, unstructured, or made by customers, what they want to buy. How we create an information system has two ways. We can do it top down, a very structured design, or we can do it bottom up. We can create a prototype. Here, let me write that in here. You can create a prototype and then build upon the prototype. It really depends on how critical the software is or what it's going to be used for. Let's go through the process. We have some idea, a challenge, a problem. We have something that would either make our lives easier, make our product better, maybe make our product our service or product different than somebody else's service or product. So we investigate somewheres, and then we analyze, and somewheres we get a return on investment. And that typically is either quantitative or qualitative. Quantitative or qualitative. Either you can measure it quantitative or it's qualitative. It's a better service, but it doesn't actually generate money. And then we do feedback. We investigate, is this something we want to continue with? We do all kinds of analysis. We gather all kinds of information, data. And then we can move on. Then we can design the solution and create pseudocode, flowcharts. We can create all these things to make the design. Once we're sure on the design, again, we have feedback there, we can develop the solution. We can buy software to our solution, or we can create software. Also in this solution, software here, not just software, but then the software will then tell you what kind of hardware you need. So we have software, and that would determine what kind of hardware you need. And again, here, I'll do it green this time, we get a lot of feedback until we test and everything, and then we have what we need, and then we can implement. You can phase it in, you can do a complete rollover, you can do parallel where you're running two systems at once. Phase, and we would run in, turn it, do different phases. Anyway, somewhere you would implement your new solution and then evaluate it and make sure it's working. Is it really giving you your return on investment? And then if there's problems, and there will be bugs, you go back up, you investigate, analyze, so forth. So this whole process can go like this. And then eventually it goes through a life cycle to where you got to create a whole new system. The other way is this bottom-up prototype. You go through part of the process, you analyze and so forth, but then you create a prototype, and then you change and adjust, So instead of adjusting the design, you're actually adjusting what the product's going to look like. This works in a lot of situations. This works better in a lot of different situations. If your software's critical, you can't afford to have any errors, you gotta look at every possible angle, you might have to do it this way. I use the example of building a house. If you're going to build a house, you gotta have the idea, let me use another color here, blue, so then you have the idea, you build a house, you investigate, can you pay for it, how big, and then you do an analysis. How many bathrooms? How many bedrooms? Is it open floor plan? Less, et cetera, et cetera, et cetera. And then you design it once you're sure you know what you want in the house. Okay? And you'd really have to do all of these steps before you can start building. You couldn't just start building a house and then say, like a prototype, and then come back and change it, and then keep building and change it. But for me, I built a tree house once, and I built it using the prototype idea. I put a board on a tree, made sure it was high enough so I could mow under it, and then I started adding stuff. Okay, so I prototyped it. So it changed many times before I got done. But I could do it that way, and it wouldn't have been a disaster, because if I really would have messed it up and had to completely start over, I could have done that with the treehouse. It wouldn't have been the end of the world. Okay, so we're still, oh, let me change color here. We're still, this is week 14, and now this is day 38. Do your best work here at the end. Yeah, information data assurance is a great class. We're talking about antivirus. Anyway, here's what we're talking about. Introduction to computers. More database work. Program development. Database management systems. Group work. Here we talked about, well, first of all, security issue at Mercy. They had an internal breach in which they had 2,000 records they had to send letters out to the people. We talked a little bit about that. We also talked about, we watched a video on Google Ventures. It was with Gimlet startup, and it showed how they do a sprint in which we talk about that. That is more of a, here I wrote it over here, a bottom up. You build a prototype and then you just build upon that. In comparison to the development of a lot information systems where we do it top down, we have a problem, we investigate it, we do analysis, we design, we develop how we're going to develop it, then you put it into place and evaluate, create this cycle. And it has a life cycle too. This, in sometimes, is called a waterfall. Okay. This is often called agile programming. Let's take a look at it. Program design in general. Okay. We'll look at that later. Here we have, I talked about, we create tables in databases. Makes it easy, keeps it more accurate. When we create two tables, between those two tables, if you remember, you have a primary key that links to a foreign key. And when you do that, you build a relationship. Build a relationship between those. Now, it's very important when you have your primary key connecting to your foreign key that this has values that match values in here, so the database can build a relationship. For example, if this has IA for Iowa, then it's going to look for an IA for Iowa down here. It wouldn't work if it was IA here and IOWA down here. A computer couldn't match that. That wouldn't be a structured decision. I couldn't do it. Okay, this is finishing up week 14. There's only 15 weeks total, so we're almost done. This is Friday. This would be day 39. I may be off one or two. Now, the network tour is this coming Wednesday. Okay, so we have intro to programming, information data assurance. Here we talk about endpoint security. Pretty interesting. I think it is. A couple vendors that do endpoint security. Let's get to BCA. We talked about coding, trying to understand that project, and then group work. So how do we develop software? Us or Microsoft. First of all, some people claim HTML is coding. I don't. It's a markup language. It's referred to as a markup language. use tags to get things to do what you want it to do in a browser. Not true programming in the sense that we're going to talk about here. We're going to talk about developing software, writing some type of code. Why do we write code? To get solutions and for computational thinking. A little bit harder to grasp. People will say, well, I don't need to learn any code, whether you call each one of these code, because I'm not ever going to write code. Well, that is a problem in the world because we're not moving away from digital representations of our world, and digital representations are manipulated using computational situations, algorithms. And even if you never write or work directly with an algorithm again, you will live in a world that's constantly working with algorithms and those type of things. So, we have a problem, a challenge, and then our next thing is, can software solve that problem? And a lot of times there may be large software packages that address that problem, but they're either too expensive or too hard to work with. So sometimes we want to develop a small solution. And where that's changed in the world tremendously is people want to just develop a small app or a small piece of code to attack some little problem that's developed out of the bigger things we're doing, either in life or business or whatever. So we did a little review. Software is the same thing. We analyze the problem, we design a solution, we can develop the code, and then we implement and test our code, and then create updates to the code. You should be updating your software on your PC or your phones or your laptops or your tablets all the time. And again, here we can do this bottom up also. Quickly create some code and then keep improving upon it. Prototype. Do you remember the C's? Can we communicate? Do we critically think, which is really important with fake news nowadays? Do we collaborate? Can we communicate and collaborate to solve problems? Problems are usually too big for individuals to solve. Are we creative? And can we do computational thinking? They actually call this the 4 C's for the 21st century. The last slide. So, in the world of technology, we have what we call source code. So when they say it's open source, they are referring here to the source code. Open source means you can change the source code. Somebody writes the source code and you can use it and change it. Most people think that means free, which is typically true also. We write programs using a programming language. We listed some: C#, C++, Python, Java, JavaScript, PHP. These are some old ones: Fortran, COBOL, Fortran, Pascal. Those are some of the old ones I learned a long time ago. So we follow some syntax and we write code that humans understand. That's called source code. We use a piece of software called a compiler that converts it to an object code. That's something a machine understands. You might think of it as machine language. This, or sometimes they call it's interpreted. Interpreted means it's going to be interpreted and executed, and you're not going to have a compiled form. A little harder to understand. This whole process, though, can be easy to understand. This whole process right here can be thought of like an interpreter. We have English, and we need somebody to interpret it to Spanish, let's say. English is our language, and let's say Spanish is the language of the machine. So, we take the source code, and we'll look at, one day, we'll just look briefly at this, and we create object code. We write the source code, it becomes object code, something the machine understands. We bring in extra things from a library, extra code, and we create an executable. Something like that we've used, putty.exe. This is software that will execute based on an operating system that it was compiled for. So at Microsoft, they write Microsoft Office in some language, probably, I would guess, C++. No, actually they write most of their stuff in C#. So they write it in that language following the syntax. They compile it into the Office package that we run on Windows. If they want to run on a Mac, they have to compile it to run on a Macintosh if they're going to run it on Mac operating system. That's why software is not always compatible, okay, directly, because Android is compiled for an Android operating system. iOS is compiled for an iOS operating system. We use the correct interpreter to make it work. That is it.